Good morning, everyone. Today's video is all about the ideal heat and engine. Heat engines convert the fuel chemical energy into thermal energy and utilize it to do some mechanical work or a mechanical energy. Types of heat engine is external combustion engine and the second is internal combustion engine. First is external combustion engine is for example is steam engines are external combustion engines where the working fluid is separate from the combustion product. The second is internal combustion engine. So typical example of internal combustion engine is an engine used in automobile in which the high temperature is achieved by burning the gasoline or mixture in the cylinder itself. Carnot heat engine define a theoretical engine that operates at Carnot cycle. Developed by Nicholas Leonard Sadi Carnot in 1824, it gives the estimate of the maximum possible efficiency that a heat engine during the conversion process of heat into work and conversely working between two reservoir and can passes. Carnot theorem define on any system working between two given temperature 1, hot reservoir, and temperature 2, cold reservoir, can never have an efficiency more than the Carnot engine working between the same reservoir respectively.
Main parts, namely the cylinder, source, sink, working substance, and an insulating pad. Let us now learn about these main parts. Cylinder. The main part of the Carnot's engine is a cylinder with perfectly insulating walls and perfectly conducting base. It is fitted with a perfectly insulating and frictionless piston. Source. The source is a very hot body maintained at a fixed higher temperature and has infinite thermal capacity. By infinite thermal capacity, we mean that any amount of heat can be taken out of it without changing the temperature of the source. Sink. It is a body at a lower temperature T2, and it also has infinite thermal capacity. That is, any amount of heat can be added to it without changing its temperature. Working substance. The working substance in the Carnot engine is the ideal gas, which absorbs heat from the source, does some mechanical work, and rejects the remaining amount of heat into the sink. Insulating pad or insulating stand. During the operation of the Carnot cycle, the working substance undergoes adiabatic expansion and adiabatic compression. The cylinder is placed on a perfectly non-conducting stand which thermally isolates the working substance inside the cylinder from the surroundings. To get continuous supply of work, the working substance is taken through a series of operations called the Carnot cycle. The Carnot cycle consists of two reversible isothermal and two reversible adiabatic processes. Shown here is a Carnot cycle obtained when an ideal gas is used as the working substance. The ideal gas is taken inside a cylinder fitted with a piston.
Carnot realized that the efficiency of a heat engine depends on the temperature of the hot and cool reservoir. Engine will be most efficient of the process. So generating works were reversible if we could return the heat that we move from the hot reservoir to the cold reservoir, returning to the hot reservoir, allowing the cycle to repeat forever. Okay, so in these slides, we will talk Carnot cycle. Carnot cycle is defined as an ideal reversible closed thermodynamic cycle in which there are four successive operations involved, which are isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. During this operation, the expansion and compression of substance can be done up to the desired point back to the initial states. Sadi Carnot cared about reversibility. The most important matter are the temperature of hot and cold. The first Okay, so there are the first step of the Carnot cycle. So first is isothermal expansion. So heat is absorbed from the reservoir at the temperature. So isothermal expansion, heat is absorbed from the hot reservoir at temperature because none of the heat gives into a changing the temperature of the gas. The heat goes into the pushing the piston as the gas expands. So I'll give some picture class. So this causes the substance to expand from volume 1 to volume 2 and hence to perform works and surroundings. But when with a cylinder is open at this stage, the temperature remains constant. Step 2, the adiabatic expansion. The gas expands adiabatically from pressure 2, volume 2, temperature 1 to pressure 3, and volume 3 to temperature 2. So it means the cylinder is then sealed and perfectly insulated, so no further heat is supplied and lost from the working substance. So this means the substance continue to expand adiabatically, defined as occurring without loss or gain of heat from the system during this stage. The volume increase from the volume 2 to volume 3, resulting in a fall in the temperature from T1. Here are the picture of the Carnot cycle step 2. So there are the step 3, so isothermal compression. The gas is compressed isothermally from the state pressure 3, volume 3 to temperature 2 to pressure 4 to volume 4 to temperature 2. So here the work done on the gas by the environment is given by. It simply means that gas compress at this stage. While compressing the gas, always consider the simultaneously holds the temperature of the gas constant. Instead, the heat is transferred to the cold reservoir. There are the step 4 of the Carnot cycle, adiabatic compression. The gas is compressed adiabatically from the states of P4, V4, and T2 to P1, V1 to T1. So here the work done on the gas by the environment is given by. So it simply means work on the gas but not allow transfer to the cold reservoir. That heat has to stick around inside the piston, causing the temperature of the gas to rise back to it. What exactly is the Carnot cycle and why is it useful? So, defined as Carnot cycle is a Diel heat engine cycle which is totally reversible. For example, the system undergoing this cycle will not have any reversibility losses due to a friction and heat loss. So Carnot did not just want an engine, he wanted a good one. Carnot efficiency of the Carnot engine depends only on the absolute temperature of the hot and cold reservoir. So, in conclusion, Carnot engines still obey law of thermodynamics, which states that it's impossible to turn all of the heat energy into work. So, although, in reality, no system or engine can be totally reversible and will definitely have some reversibility associated with it. So, but Carnot cycle is a highly useful a benchmark to design any engine that produce network output so that we can strive to achieve a better performance. Okay class, so that's it for this video. I hope you can get this video. Okay class, thank you.